All right, what I want to do is stop here and just answer questions about either the paragraph or the two-column proof while I have both of these up. I think that's a really good time to just take a break and stop trying to absorb information and let's process it for a few minutes. And then once we're done processing it, we'll move on to basically question and answer time about part 2. And then after we answer questions about part 2, we're going to do share some ideas. What would you have, like Jasmine did? That couldn't have been any better. She said, I took a picture of a railroad crossing sign. Could we use that? Yes. You could say, okay, I have a picture of a lighthouse that I took last year. I want to use that. I'll pull up a lighthouse and I'll show you exactly how we can do it. And then by the time we leave, you should have a lot of good ideas. QED does not go after a 2-column. QED only goes after the full paragraph proof because it is Latin shorthand for that is all. At least that's what I was told. I don't speak Latin, and I'm just going to assume that it does stand for that. Dr. Garman was a pretty good guy, and I don't think he would make that up. So QED just means that is all, or this is it, or we are finished. I think he used those all interchangeably, as translations from dead languages can collide often, not always be the same. But yeah, QED only after your paragraphs, never after your 2 columns. So QED there, but this is it. Once I see that your conclusion has been reached, I know you're done on a 2-column. Everything else in this document are YouTube videos that I put up. This is basically that bike picture above, but where I decided on how to set this up for these proofs. In this video, I also use this house in the background, which is much easier to see, and this eroded dock, where I then show you from one picture I was able to find 3 different things I could use for proofs. Obviously, you only get 1 proof per picture, but it is very easy in any picture to find at least 1, if not 2 or 3. Any other questions about 2-column or paragraph proofs before we move on? The question about QED was a really good one because I would give you a note saying don't do this in the future, and a lot of teachers would mark you off for putting QED at the end of a 2-column proof.
I have another question, but it's not about the paragraph in 2 columns.
What's it about?
So, from on the chart you listed different interior something.
Hold on one second. I heard you say from on the chart, and then I lost you. Now you're back. So,
For the theorem, the triangle interior sum theorem, like would a hanger be able to use because it's like kind of a triangle, or would I have to find something else?
Thank you again. Perfect question. So when you have you're talking about like a wire or a plastic hanger, right?
Like a plastic hanger.
And the worry is those bottom ones are a little bit too rounded, right?
to make an actual triangle. So let me show
So I'm
you.
kind of confused.
So remember how I always say in geometry you get so much freedom that you can just say whatever you want is true. Basically, let me show you what I would do. I'm going to pull up a picture of a plastic hanger. And I'm going to show you why you can definitely use this one. One of the reasons I want you guys finding original photos just like Ben's been doing is because this shows me that Ben's starting to really understand that this is everywhere and that you have some liberty in geometry. So when you turn in your paper, this is what I would turn in.
But mine had like little hooks underneath, so is that a problem?
Like right here.
No, like in
Oh,
I know what you're talking about. You're talking about on the inside. They're like this. Let me see.
yeah, they're like right there.
That doesn't stop that from being a triangle, right? If anything, I would say you can call this an isosceles triangle by using the hooks. And I'd probably give you a bonus point for being not only creative, but just dedicated to having such a good writing assignment. But yeah, don't let anything like that, mess it up. That's like saying if I had a picture of a window that did this, but then there was a tree in the background that kind of messed it up. I'm only worried about what you tell me is true, and that's your given, so you're good to go. Does everyone understand what Ben's concern was at first? It's that this rounded part kind of doesn't make a triangle. But if Ben can draw this and show me that it is a triangle inside, I'm perfectly fine. Here's angle 1, here's angle 2, here's angle 3. And now I can see that through Ben's eyes, this is a triangle, and she can prove any of that. Now, what I would recommend you do, Jim, is whatever you do for your, and some of these you're going to write these and say, oh man, I could have just done this for a couple of them. Your your interior angle for the triangle can also be used for your exterior. And what I'm going to say there is this. I'm going to give you guys another shortcut. When I draw this, how would I go about proving this? Well, I'm going to extend each of these lines. Because I know that the sum of the exterior angles must always be 360 degrees, right? So if I'm proving I'm going to do the interior in purple. If I'm proving the interior, I can't just say that if this is 60, this is 60, that's 60, because then I'm using the interior angle theorem for my proof and for its definition, and that messes everything up. What I could say is that this is 120 degrees, this is 120 degrees, and this is 120 degrees. And why can I say that? Well, for this one, I would say that this is given because of the exterior angle theorem. And that just means that the sum equals 360 on the outside. Why is that important? Because for the rest of these, this is P1, P2, let's call this angle 1, angle 2, angle 3, is for all of these angles, I can say angle 1 plus 120 equals 180, and the reason for that is the linear pairs theorem, right? Because from here to here is 180 degrees. That means that angle 1 is 60. This would be your subtraction property of equality. And then P4, P5, I would just copy paste this and change angle 1 to angle 2. Copy and paste that, change angle 2 to angle 3. And then all I have to do for P6 is show that. And I'm done. Now, what's nice and really smart about choosing here to use a coat hanger is simply this. Once I finish this, all I have to do is move this angle to the outside and change it from 120 here to 60 on the inside for all of these. And now I've done both proofs, and I can just copy and paste the previous proof and I'm done. Now that's a lot to absorb, I know. And we're getting down to the last 38 minutes. So I'm going to ask you guys, would you rather see me just write up one of these two proofs for this so that you can then go back and switch them? Or do you want to ask questions about part 2 and then start playing the rapid fire game? And by rapid fire game, I just mean exactly what it's been doing for us. Asking, would this work? And I say yes or no. I've got 1 vote for proof, 2 votes for proof, and we have 5 people in the room. So we are at a majority for proof, so let's do it. So first let me start by, okay, now we're at almost 100% for proof. So I'm going to close this, and I'm just going to start setting up. I'm going to choose to do a 2-column proof, only because, like I said, you guys can easily turn this into a paragraph proof. Thank you, sir. Oh, he left quick. He was just saying thank you. All right, so a 2-column proof of the... You want the interior or exterior?
Which one's better?
I think if we start with the interior, it would be better for you to see, because it's kind of hard to word the exterior theorem that we're going to be using as our proof that we can even do this. So let's do exterior, and then I'll show you how to change it to interior.
Okay. And I found the hanger out, so it's just a plain electric picture.
Okay. Either way works. I mean, thank you for having all these questions ready ahead of time. It keeps us much more efficient. So this is the 2-column proof of the triangle exterior sum. So what I'm going to do is come in here and copy. And I'm going to scroll down to the pretend end of it, put a page break. Not right there. Put a page break in because I have to put my original photos at the bottom. So that's that. Now I'm going to come back up top and I'm going to start writing my givens here. So first I have to know that we have a triangle. So I'm going to draw in my triangle in not that color, this one. So I'm just going to start here and I'm going to do this, this, this. And what I'm going to say is I'm going to label my vertices. And now I have triangle ABC. That's already a given. Just because I don't want to confuse myself later, I'm going to add my extensions in a different color so that they go like this, and like this. And what I need to say here is that angle. So now I have to add D, A, B is 120 degrees. And then, and Jasmine, I'm just going to stick with the thing we said earlier. I got to go back to red. I'm going to make this an equilateral instead of an isosceles. Always, if you're doing generic triangles that you get to create, always make them an equilateral. And the reason I say that is once I can show one angle, I can say by the definition of an equilateral, all the other angles are the same. And look at, I mean, if you're watching this video, rewind and look at how many steps I just cut off. I cut off, what, 4 or 5 steps just by making this an equilateral? It's going to be 4 because I have to add the information as equilateral, but here we go. This is really all we need to do this entire proof. So now that I know I've drawn everything on that I think I need, I'm going to go ahead and copy it. I'm going to make it a little smaller so it fits up there. And now I make it a little larger so that it won't have to be down here. All right. So now I have my picture and I'm going to start my proof. I don't know how many steps I need yet, so I'm not going to make my table yet. But I do know I'm going to be doing a 2-column proof. So what I'll do is I'll just take a new screenshot here and we'll use this blank canvas to work this out. So my P1 is always whatever is given, and my Q1 is always going to be given. Now, it's a minimum of 1 here, but it could be, you could have 10 pieces of given information and you would have 10 entries all the way up to P10 that would be given. So our first thing that we're given is we have triangle ABC is equal lateral. And we can all agree with that, right? I marked it equilateral, so triangle ABC is equilateral. My second thing is that the measure of angle DAC is 120 degrees. That was also given. You were asking earlier about how do we know what's given, and I mean, when we were in tutoring the other day, that was where your major struggle was. Notice here that I took Jasmine's question about the hanger and I just drew pictures on it, and I'm just filling in information as I go. Oh, that's not what I want there. What would I write for Q2, guys? If it's on the hanger's picture, it's always given. So now I've covered pretty much everything. ABC is an equilateral, and it's a triangle. That was given. And DAC is 120 degrees. I'm saying from here, that's more than enough information to do this entire 2-column proof. Let's see if that's true. My next step would be that I'll write it this way. The measure of angle DAC plus BAC. Wait, why DAC? DAB, guy. Attention to detail. DAB goes here. And I'm using that plus, and now I'm going to go from B to A to C. Must be 180. Because these are linear pairs. If I go from here to here, I've got a linear pair. So LPT means linear pair theorem. My fourth step is that DAB is already known to be 120. So that plus BAC equals 180. I would just say I'm doing substitution. And the reason I didn't have substitution before is I did it much more efficiently. But right now, just know that the reason I'm writing substitution is that I've taken DAB to be 120, said DAB plus BAC is 180, and I substituted the 120 for the DAB. And that means I've done substitution. And now for my fifth hypothesis, BAC is equal to 60 by the subtraction property of equality. Now, the reason that I'm glad I've been asked about the little hooks in there, and I said, let's say it's an isosceles triangle, is then that kind of made me think, well, why make it an isosceles? Why not go that one step further and make it an equilateral? And the reason I can do that, or the reason I wanted to do that, is that BAC is congruent to, so I'm going to turn on my annotation so you can see what I'm thinking. I've already shown that this one here is 60 degrees. And since we know that the side or the angle generates the side length, if all the side lengths are equal, all the angles are equal. So now I can say that angle ABC is congruent to that. And angle B to C to A is congruent. And that is just the definition of an equilateral triangle. So what does that do for me? Well, if BAC is 60, then I know that this is 60 and this is 60 now. So my seventh hypothesis is simply 60 plus 60 plus 60 equals 180. Q7 is just addition. We'll call it substitution and addition, since we're doing two in one step. Technically not supposed to, but I will allow it at this level. And my final is that the sum, that's a really bad symbol. I'm just going to write the word sum of angles equals 180. And that means my final conclusion is that I've shown the triangle interior sum theorem. So could we follow all of that to get an answer? Easily. This is going to get erased. That would be it. That's what we would turn in if you have a picture that matches that. This is a really good one to write as a paragraph, because explaining these steps is really easy to do, especially stuff like here. If angle BAC is 60, then ABC and BCA are also 60 because this is an equilateral triangle. You can actually write this one really efficiently as a paragraph. So this would be a great one to do as a paragraph. Now, I'm going to do this really quick. This was the interior, right? We concentrated on finding the interiors. If you want to do the exterior, I would do the same thing. I would draw in my triangle. And the triangle exterior theorem just tells us that the sum of the exteriors equals 360. So what I would do is come in here and show that this is an equilateral and that all of these are 60 degrees. See how we're already at our conclusion, but now we're doing the opposite theorem, so we're going to have an opposite hypothesis and an opposite conclusion. I'm going to come back and extend them like I did before. So now, what we'd want to do is draw ABC the same way we did before. Let me switch over to my pen. A, B, C, and then out here was D. And now, instead of writing DAB is 120, that's what we're trying to show. So this time we're going to write BAC is equal to 60. But then, when I change this to BAC, plus, well, actually that line we don't have to change, right? Because we're still looking at DAB, which is right here, plus BAC would have to be 180. But this time, we know that BAC is 60. So we keep this as DAB, and we get 120. Well, that stays 180. But this time we see that DAB equals 120. And then we can follow the exact same steps after that and have our finalized proof. So you see how I just, on the first one, I found the outside angles. On the second one, I found the inside angles. And then I could follow the same steps to end up with that 2-column proof all over again.